Greetings everybody from Orlando. We're here at that ARC Executive Forum and we're here with Luis of ABB. Welcome.
Thank you, Lucian. Thank you for having us.
Thank you. Now, the talk of the day is software-defined automation. I'd like to ask Luis, what is your definition of that? Everybody has a different definition, different company, but your personal one, maybe go from ABB's perspective.
Yeah, I think that is a very good discussion point, and I'm glad you brought it up. I will start, some of what we see as software-defined automation is really a response to what has been traditionally the automation solution, where we have software tightly coupled to a specific hardware platform, where we have different components tightly integrated into a kind of sort of a modular, but a sort of monolithic at the same time, very tightly connected. So when ABB started to look into this and join certain industry initiatives like OPAF and modular automation, etc., we started to look into how do we read modular automation, OPAF, and because we cannot produce products for a particular industry standard, we have to address the industry needs in general. So for us is, first of all, let's decouple hardware from software, period. Meaning your control applications, your operation screens, those things have to be decoupled from a specific, tightly defined hardware platform. Second, the hardware platform also have to be more decoupled and modular in that sense. So we need to have more modular I/O, more of, let's say, network-centric I/O rather than I/O tightly coupled to a controller. That way you have the flexibility to deploy the software to different computing platforms, right? And then to spread your system more broadly. We need to integrate the physical world with the digital world. For that we need an information model. We already had an information model that has been working for our systems for many, many years. And we use that not only to bring that physical connection to the control applications, but also to bring that information to the digital environment in which we can bring then more, let's say, richer applications to complement what is happening typically in the control. So in a nutshell, network-centric I/O, decouple software from hardware, and a solid information model to not only associate a particular measurement of the field or the physical, but to also provide the context of what's happening, where is that signal coming from in the plant, and what is that asset associated to that signal.
Got it. So it isn't necessarily the traditional hardware simply couldn't keep up with the speed of the 2026 market, but perhaps that maybe it backs the question, is the era of rip and replace upgrade officially over, or?
For ABB, it's been a strong objective for decades to avoid the rip and replace.
Okay.
Right? We have been working, our strategy is summarized in a sentence: innovation with continuity. We want to bring innovation, but we want the user to preserve the investment they've made, either on the applications that they have developed on the hardware platform that we have provided, or even to support them over the lifetime of the asset that they're running. And for that, we have gone through hardware renovations, multiple steps, trying to ensure that they don't have to touch the wires and they can preserve that installation, that asset, over the life cycle they need. Is that possible in all cases? No, unfortunately not. But, the effort is made so you can port your applications, right? Especially in this model of software-defined architecture, you can port applications from existing controller platforms to a different version of a different hardware platform, or even a non-ABB hardware platform eventually, right? So it's all part of the evolution. But I don't think the rip and replace is going to be completely disappearing from the space, especially because we have a lot of assets in the world that have been operating for decades.
Got it. So let's double click a little bit. If we decouple the software from hardware, is it like a flight simulator? Can an engineer test theoretical AI optimization in a digital sandbox without any fear of the real world plant feeling of the impact? Or
yes, but it's more than that. We are doing that we have been doing that for several years now. There are other technologies that have supported us to do that with virtualization, so we can do actual virtual FATs, right? So we can
Factory acceptance tests, yes.
Yes, we can do the design, engineering, testing, all in a virtual environment, and then minimize the activity on site to when it's actually needed. But this is beyond that. It is being able to, yes, you can do that, those type of virtual, like as you say, flight simulator type of things, but it's the real plant, right? But at the end of the day, you need to make sure that the computing hardware that you have used to deploy your applications are up to able to really host the applications and run the plant.
Got it. I want to pick up on something and maybe talk a little bit about some of the risks that manufacturers underestimate when moving towards software-centric automation, or as you've been innovation with continuity.
Yes. So, I mean, not every case will be the same. So there's a level of analysis that has to be done into each user situation, right? So, and I think that that's something that is important to mention. And not every user wants the same thing from their suppliers or in the marketplace. We see that in all industries. Otherwise, we wouldn't have this many, car manufacturers in the industry, for instance. But at the same time, there are general principles that I think need to be preserved. I think that the interoperability is important, the ability to bring different elements from different manufacturers, the protection of the life cycle, it's important. Different software design methodologies that are better tuned to the kind of the new the new engineers coming into play in the automation. We need to understand that the automation industry, especially today, is facing different challenges. Some are technology and some are human-based. And the human side, we have a generation of professionals that are at some point in time leave the industry, and we need to make sure that the newer generation coming in has an environment that they are comfortable, that they know how to work with. We cannot stick to the way it was done 40 or 50 years ago.
Got it. I want to end with one question. So what is the smoking gun that tells a CEO their software-defined investment is actually delivering value?
That is a tough question, and not all the cases, again, are going to be the same. Let's get that out of the way first, right? So each user will have a specific use cases and requirements. Having said that, I think that in my view, how much can you run the asset that you have? I mean, this for ABB, again, we have let's say many systems, or a large install base, let me just say it that way. And we are working with our users to protect their investment. That is a top priority for us. Why? Then the software-defined automation. We want to make sure that working with our customers, we can extend the life cycle of the automation solution by bringing innovation in that continuous environment. And that means that there will be different KPIs.
Yep.
Can you port your applications to a newer generation of technology? That might be a KPI. Can you totally decouple and run in a standard general purpose computing environment? That might be a KPI for some. But then at the end of the day, is your plant running? Is it running safely? And is it reliable and resilient? Those are the KPIs.
Luis, thank you so much for your insights. And if your audience have questions about software-defined or other things that you've launched this week, feel free to leverage the hashtag on the screen. We'll get the appropriate people at ABB to answer them.